دكتور عادل صباح الخير، وشاكر على التقديم الحلو ده، وسعيد اكون معاك ومع الدكتور هشام عوض، وطبعا مع اخويا الدكتور محمد البربري. وشايف الدكتوره سناء جايه من امريكا، ما اعرفش جايه لمحاضرتي ولا لا، بس سعيد سعيد ان انا اشوفكم. انا محاضرتي حوالي 25 دقيقه، وبشكر هشام بالذات لان الاوبننج برزنتيشن كان المفروض تبقى الدكتور هشام، بس يعني بكل كرم اداني الاوبننج سلوت عشان عندي محاضره بعدها. لا، ما انا عشان كده سايبهم على الشاشه، ما انا قلت اسيبهم على الشاشه علشان يبقوا موجودين. انا بدون الشاشه دي ما اعرفش اقولهم يا عادل نفسي، بس المربع ده مش من عندي الحق، فده من الاورجنايزرز. هو غالبا اوفر فلو من الشاشه اللي قبله، فعمل. طب انا مش عارف لو هيكمل، لو احنا كده نقول في الجنب. اوكي، بس لا، ما زال موجود معنا. اوكي اوكي. هو ده very short bio عني. هو انا دكتور اشعه، انا استاذ في جامعه قناه السويس، بس طبعا انا ابن عين شمس قلبا وقالبا، وقعدت لغايه الدكتوراه واشتغلت معاك كلكم الحق، الجيل اللي هو القديم بتاعي. ودخلت في عالم الذكاء الاصطناعي عن طريق حبي للادفانس تكنولوجيز، وعشان انا انفولد في شركه متخصصه في الارتفيشال انتليجنس، وده بيحطني في وضع او في موقع فريد قوي، ان انا بشتغل كلينيكالي بس عندي اكسس لكل التولز بتاع الارتفيشال انتليجنس، فبقدر اشوف ازاي التولز دي بتحل مشاكل من اللي انا بشوفها افري داي ليا ولزمايلي. فده البريف بتاع الباك جراوند بتاعي. العنوان زي ما الدكتور عادل قال هو AI in Pediatric Imaging Today and Tomorrow. وعلى الرغم ان احنا دايما بنبص لل AI ان حاجه المستقبل، بس احنا عايشينها actually every minute of the day. دول الديسكلوجرز بتاعتي، ما فيش حاجه منهم conflicting with the nature of this presentation. الاجنده هبدا بانترودكشن عن الارتفيشال انتليجنس، وبعدين هتكلم على التشالنجز اللي احنا as radiologists وانتوا حتى كبيدياتريشنز بتقابلوها في البيدياتريك ايمجينج، وهتكلم على شويه من الابلكيشنز اللي بتسهل لي المهام بتاعتي في الايمجينج، وبعدين في الاخر هرفلكت وراب اب. دايما بحب ان انا ابدا بالديفينيشن بتاع الارتفيشال انتليجنس، لان في ديفينيشنز كتيره قوي للارتفيشال انتليجنس، انما اكتر واحده بحبها هي ابسطهم، وهي اللي بتريفير للارتفيشال انتليجنس كتكنولوجيز capable of emulating human intelligence. التعريف الاهم هو تعريف الهيومن انتليجنس. ايه هو الهيومن انتليجنس؟ هو المقدره to solve problems through learning and reasoning. وده exactly what artificial intelligence does. Learning and reasoning. الراجل ده ألان تورينج، mathematician من بريطانيا، وهو credited with coming up with the idea of having machines think. وفعلا نشر البحث بتاعه سنة 1950، إنما كان mostly theory، لأن ما كانش عنده technical abilities إن هو to put it to practice. وللأسف مات سنة 1952 قبل ما يشوف أي حاجة من الثيوريز بتاعته تتحقق، لكن it took حوالي 60 سنة to have proper working models with the arrival of deep learning models على ايد ناس زي جيفري هينتون ويان لاكون وفيفي لي. ال deep neural networks emulate the way our brain's neural networks actually functions. ليه خد 60 سنة؟ علشان الفكرة بتاعت ألان تورينج تبقى رياليتي، لأن كان لازم ingredients كتير to come together. واحد منهم كان لازم يبقى عندي big data علشان الكمبيوترز تتعلم منها. طيب لو عندي big data أنا محتاج algorithm تتعامل مع البيج داتا دي، ما كانتش موجودة لغاية very recently. وبعدين كان محتاج الكمبيوتر power to deal with all of this. This has only come together in the 2010s. فبعد 60 سنة بقى عندنا working models of artificial intelligence. In fact, as we speak today, كل واحد فينا is engaged with artificial intelligence mostly unknowingly. يعني face recognition of your phone لما تصحى الصبح وعاوز to unlock ويشوف الوش علشان يعرف ان هو ده صاحب التليفون. This is artificial intelligence. Social media is totally controlled by artificial intelligence. In fact, without artificial intelligence, all these platforms would crumble. Voice recognition. Aviation, واحدة من early industries that actually used artificial intelligence to fly planes. In fact, most of the flying is done with artificial intelligence tools. Google Maps or Google Search, banking security, Netflix, even your shopping on Amazon is actually powered by artificial intelligence. فكل واحد is unknowingly using artificial intelligence. We've only become conscious that we're using artificial intelligence مع الادفنت of ChatGPT, لأن for the first time we were able to communicate with artificial intelligence the way we communicate with others. النهارده بتكلم ChatGPT وتسألها ترد عليك وترجع تكلمها. That engagement has only come 2 years ago في أول 2023. Let's get a bit clinical ونشوف ال challenges that we're meeting in pediatric imaging. Now, إزازة أو الكان بتاع الكوك دي أتخيل إن إحنا شايفينها كلها لونها أحمر. I hope. ودي واحدة من challenges we meet as radiologists. So we all agree that this is red. بس لما تكبرها not a single pixel is red. But how do we see it as red? Because the way our brains are wired teaches us to perceive images based on experiences. So out of experience, we know that a can of Coke is red. So we make this up because the image is just fuzzy, but not a single pixel is red. And this is one of the main challenges we face in radiology. We are our own challenges because our perception abilities are limited. So do we really need AI? Yes, we do, because of our limited perceptive abilities. But there are other reasons. Now, in pediatric imaging, just like in any other form of imaging, we are facing workforce shortages, while the workload is actually growing. To make things worse, subspecialty shortage, and I'm sure you're aware, very few radiologists do specialize in pediatric imaging. Scanning challenges. We're having to deal with very advanced technologies generating enormous amount of images that we can very hardly deal with. And then we've got diagnostic challenges because we're seeing even rarer and rarer conditions. So we've got that gap between supply and demand, which for all we know is set to widen. So we need some kind of help. Why? Because the expectations from us, despite all these challenges, is to actually perform better. And what we deliver is backlogs, errors, and burnouts. We cannot meet our expectations. So something has to happen. And this is AI. We, as radiologists, in the 2010s, that's about 15 years ago, started to notice that AI might provide a solution or support to our needs, and started research into AI tools. Now, this is the number of research in AI in imaging in general. Till today, we've got about 38,000 articles published on AI in imaging, just imaging. However, pediatric imaging, just about 1,000. So that's about 2%, 2.5%. Not so much, so that's a challenge. But why do we not have so much research in pediatric imaging, AI? Because of the small data sets by nature, smaller population. And it's a very heterogeneous population, and the normals vary because pediatric refers from newborn till 18, or even an FDA definition 21. So that's a very variable normals, and a lot of rare diseases, and it's artifact prone. Kids move and breathe, and you cannot really control them. With all of that, it's not really attractive to get into research in AI and pediatric imaging, basically because your source images are not that much and not that good. Regardless, researchers did get into the scene, and today we have about 1,000 FDA-approved AI applications. Of those, almost 800 are radiology related. And you would be happy to have 80% of your AI tools in imaging. However, pediatric related tools in the world of AI are few and far between. In fact, about 2%. So not that much really. So that's another challenge. We don't have so many tools. But let me see if I can show you some of the tools. And all of the tools actually have one purpose. They promise to improve the patient care with better productivity, efficiency, sensitivity, turnaround times, and it actually promises to improve the whole value chain of imaging. Remember, the value chain of imaging does not stop at just a reading. It starts before a reading when you're ordering that procedure all the way to communicating the results. AI impacts every link of that chain. Let's look at some of the applications we have in pediatric imaging. Of course, the sexy part of AI is the reading part. That's what AI is well known for, being able to read, to analyze images. And right off the bat, bone age. That's the most mature, and I believe that's a very helpful tool that's accessible to pediatricians, whereby the image of the left hand of a child is analyzed, and you get the exact bone age, and you get quite a few things in addition. Estimated height, prediction of height after treatment, and statistical metrics as well. And that's a very, very mature, and that saves us a lot of time as radiologists having to go back to our Grolach and Pyle atlases, just trying to match the images. So that's a very mature, and it was one of the very first AI tools in pediatric imaging. Nodule detection. A 2 or 3 centimeter nodule is not really much of a challenge, but a nodule such as this, hiding behind the rib and not that big, is not so easy to pick up. I would miss this nodule myself any day. How about fracture detection in an emergency department? Anyone can diagnose this fracture, but actually it's some more subtle fractures that you really need the help of AI to help you with. Fractures like this of the rib, again, most of us would miss that rib fracture. AI would not. But what's even more important, in that very same patient, that pneumothorax, this is what's going to kill the child. It's not the fracture. And this would be very easily missed. I was talking to Dr. Hisham last night about the problem of detecting endotracheal tubes. And we know that in a busy department, or even a not so busy department with all these tubes all over the place, not so easy to pick the tubes. AI detects the tube and also lets you know whether it's correctly placed. Another example of a tube that was placed too proximal from the carina, and another one that was actually pushed in too far, and without having to spend time just looking for the tip of that tube. Ultrasound, not an area that has a lot of tools in the world of AI, but DDH was one of the early attempts of AI to help us radiologists, where it would automatically detect and quantify DDH for a non-experienced sonographer. Now, I said reading is the sexy part, but there are the other parts. And just to quantify, in our workflow, reading images is about 20% of our workload. The 80% rest outside the reading, before and after. So 80% is quite significant. Now, the holy grail of imaging is reduction of radiation dose. Problem is, you reduce the dose, you end up with lousy images like these. A lot of noise, basically undiagnosable. And you still want to reduce the dose, especially for pediatrics, for children. So you have an AI tool that would take that low dose radiation, that low dose image, selectively denoises it, and you're back to where you should have been had you used the full dose. And you can actually reduce the radiation dose by up to 80%. So you're actually giving 20% of the standard dose. That's important. What about the MR? Magnetic resonance, the holy grail of MR is time. You want that patient to stay in that tunnel for as long as possible to pick up signal. Again, you try slashing that time, and you end up with awful images such as this. Then you've got your AI tools coming to your help and reconstructing these images and back to what it should be. You can actually bring down the time required for scanning a patient by 50%. Remember, this is just one sequence. And if you can actually bring down the time for each and every sequence, a 40-minute scan would be probably down to 20 minutes scan. Contrast medium, no one wants to administer contrast media, but we have to because we need to enhance lesions. Problem is, especially in pediatrics, you're so weary about the adverse reactions. Can we reduce contrast media? Yes, of course we can. But again, our studies are not going to be well enhanced unless you've got an AI tool that selectively enhances and boosts that contrast. And that's a case that was given, I believe, was given 50% of the dose in this case. And then by selectively enhancing, no one can tell the difference between this image and an image that has received the full dose. So not only are you helping your patient, but you're helping yourself because you're saving 50% of the cost of contrast. Contrast is not cheap, I remind you. How about generating images without scanning the patient? One of the sequences that's so important for us in MRI is a stare image, and that's what it looks like. But you need to have the patient in that gantry or in that tunnel for 5, 6, 7 minutes. Remember, that's a child. How about generating that image by using data from other images? So from T1 and T2 images, we can actually synthesize this image. So the patient spends 0 time on the machine, and you get that full sequence. So that's one full sequence generated in 0 time. What's even more interesting is being to generate images across modalities. So we've got that MRI of the cervical spine, and through AI, you could generate a CT image. So without even scanning that patient, without irradiating that patient, nothing short of magic. So that's cross-modality synthetic images. Measurements are quite tedious for us. Number one, because we cannot remember the landmarks for 150 measurements. We probably know 2, 3, 4 at the most, but we know we have to deal with over 150 of those measurements. Now, AI automatically does your measurements for you. So as you click on the patient in your PAC system, you have images such as these with every conceivable measurement on that image, automatically, 0 time. So you don't need to go back to your reference data. Segmentations, beautiful images like this are so important, especially if you're in surgery or you're contemplating some kind of advanced intervention. I remember I used to do these images, but to do one of these would have, I'm talking about over 20 years ago, would have taken me 1 full day. And I assure you, there were nowhere as beautiful as these. These are automatically done for you. Near 0 time. And I remind you that pediatric population also have problems with the teeth, and problem with dental images is most radiologists just don't care. And now we have tools that would automatically analyze pediatric images, including 3D sets, and generate reports for you. This is interesting.
After Jeff dictates the pertinent clinical findings into the Omni box, Omni report analyzes those observations and inserts them into the correct section of the structured report template. Omni automatically generates the impression.
What you've just seen is something that has come to the scene quite recently. Now that you've done your reading, you really need to communicate your results. And that's so important, that you communicate it effectively, consistently, in a structured manner, which is something I believe is not the norm. However, with tools like this, you're able to dictate in whatever accent you might have, whatever structure, whatever grammar errors you might put in to a system, a large language model that would take everything that you said, make sense of it, and then structure it and generate a structured report for you. And it does that every time you actually have a report to communicate. So your reports are going to be so consistent and so structured. So that's generative AI report. But what's better than generative AI report is this autonomous reporting. So the system looks at the study and generates demographics of the patient because it's getting its readings from AI, and it has your findings section and it has your impression, and that's all automatically without you even uttering a single word. So that's full autonomous reporting. Now to wrap up, and I think I'm very much on time, I have a few words to say that pediatric imaging AI tools definitely are way less than adult imaging AI tools. And to make things even worse, there are few pediatric imaging AI guidelines. However, the proven impact of the AI tools that we have, and not so many, actually opens the door to more AI tools coming your way through building trust. And I can definitely see that the deployment of AI in pediatric imaging is set to grow rapidly. With that, I've come to the end of my presentation. I thank you very much for your attention.
Thank you very much, Professor Ahmed. الحقيقة it's amazing إننا نعمل أشعة من غير ما حد من غير ما أحط الطفل. طبعا
هو ده الهدف.
والله
هو ده الهدف.
يعني كوني أنا by reduce the exposure to radiation by 80%, reducing the dose of the contrast media by 50%. ده إيه الجمال ده؟ ده انا خناقاتي كلها في محاضره عشان اقول يا جماعه حرام تخش تقول سي تي تشست الطفل كده يعني بدون ما تكون انت.
I would be happy to share this presentation with you, with Dr.
Thank you very much.
Dr. Brian, please feel free to circulate it.
Thank you very much. Thanks a lot.
Thank you for inviting me, and
Thank you.
Look forward to putting some of these ideas to the test. We had a discussion with Dr. Hisham, and I think we're pretty much set to start. Thank you again for inviting me, and it's been a pleasure being here.
Thank you very much. حيا شرفتنا ونورتنا والله. Thank you. شكرا. تضيفي طبعا دكتورة سناء.
Even the AI surpassed the radiologist in the field of the chest. أفندم؟ بقول إن the AI has surpassed the radiologist in interpreting chest, all the chest radiology. And the New England Journal of Medicine, actually, in just a few months ago, they published how efficacious the AI in interpreting and in all fields in the even adult and the children radiology, whether for asthma in particular, for air trapping, for the helium MRI, for the calculation of the tiny bronchular sizes. This is a kind of beyond imagination. In addition, the open evidence, it's not only the chat GPT, the major 7 universities in the States, they came up with another artificial intelligence website for physicians that you can access only through your DEA number and the license number. It's called open evidence. This open evidence is supposedly will surpass the version 5 of the AI. In the near future, in 2025, writing notes, progress notes for physicians to help everywhere. So it's a matter of using the technology to help us, and most residents, and even here in some universities, they don't round with the attendings except with the AI help. Whenever you ask a student, what is the differential diagnosis, what's the causes, in just a second they will come up, and it's beautiful, like differential diagnosis. It will surpass, definitely, because whatever they put in is increasing.
Dr. Sana, I thank you for sharing that information, and I totally agree with you. We're actually entering an extremely fascinating world of AI, and I urge you, all of you, to step in. It's a fascinating journey, and it will actually take us forward much, much faster than we ever imagined. And you said now that you're seeing chest imaging being more accurate and of course faster than human imaging, and that's very true. The one metric that we use, which is AUC, which is a mix between sensitivity and specificity, every AUC for the products on chest imaging actually beat the radiologist's ability. So that's, and I'm talking about the specialist chest pediatric radiologist. So, but there is a reason, and that's what I wanted to come to. We as radiologists trained by seeing images. We see hundreds, maybe thousands, if you're lucky enough, of images. And that's how you build up your knowledge base, and that's what you refer to when you're seeing an image. However, with AI, it's able to train on millions of imaging. So it's got the edge over you, and we've got to admit. So for now, it's a tool, it's available for us to use, and it can only amplify our abilities. I don't think it's competing really with us, because AI still needs us, but it actually amplifies and enhances our abilities. And that's why I encourage all of us in healthcare to use AI unreservedly. Thank you again.